Hey, welcome back to another video. Today I'll be continuing my Smart Security Camera Python app, and we'll be demonstrating an updated version of it that includes YOLO object detection. If you haven't seen my previous videos on this project, then I suggest you check them out so you can get up to speed with what I've been doing. But if not, here's a quick rundown to get a general idea. I've created a free and open source smart security camera software that's compatible with any IP camera that supports the RTSP protocol. The reason why I created my own app is because many retail security cameras such as Ring have had controversies recently because of privacy concerns. These cameras require you to connect to a cloud-based service in order to access recordings or use other features, which means the live video streams of your house are not private. I decided to create my own app that runs locally instead of connecting to a cloud service, and make it available for free for anyone to use. The first version of this app features basic motion detection and is lightweight enough to run on a Raspberry Pi 4. It uses image processing to detect motion instead of a dedicated sensor, so all that's required is a camera. It works extremely well, but I thought it would be useful to add YOLO object detection so that the application can be set to only record specific objects. There's quite a few things that YOLO can recognize, so I imagine this software could be used for a number of other applications as well. Alright, so now let's get started and talk about how to install and run the app. So let's begin by heading to its GitHub repository. The link is in the video description. So the first thing you'll need to do is make sure your system has the necessary software. If you're using a Debian or Ubuntu based system, then you can install the software with these commands. Now in order to use YOLO, you'll need a GPU that's capable of running it. If you have an NVIDIA GPU, then you'll need to install CUDA, and if you have an AMD GPU, you'll need to install ROCm. I've created detailed step-by-step guides showing how to install both of these, so be sure to check out these guides first before continuing. It might be possible to run YOLO on a CPU, but if it is, it will be slow and I haven't tested it yet, so I recommend using GPU acceleration instead. So after making sure CUDA or ROCm is working on your system, now you can clone this repository. Next, enter the downloaded folder and install the pip requirements like this. Now we're ready to run the application. The program works exactly the same as the previous version. The only difference is that you'll need to provide the YOLO argument along with a list of objects you want it to record. The list of valid objects can be found in the coco.names file. When entering the objects, make sure you separate them with a comma like this. I'll test it out by running it with these objects: person, dog, and cat, which means the program will only record if it detects these things. You'll also need to enter the address of your particular RTSP stream. So now I'll go outside and see if it starts recording. And as you can see, it printed the message and started recording right when I came into view, and stopped shortly after I left its view. If you're using an AMD GPU, you might see a bit of lag and dropped frames when the recording first starts, and might also see a warning like this, but you can safely ignore that as it doesn't affect the program. Now I'll quit the program by pressing the Q key and run it again. But this time I'll only enter dog and cat, not person. Now I'll go outside again and see if it records or not. If it's working correctly, then it should ignore me and not do anything. We don't see any printed messages, which means it didn't start recording, which is exactly what we wanted to see. Now let's take a look at the recorded video. There's only one video here, which is from the first time I went outside. It looks good and is working as expected. So running the program is as simple as that. Something else to keep in mind is that there are different size models for YOLO ranging from nano, small, medium, large, and extra large. By default, the nano size model will be used, but you can change this by adding the model tag and enter the appropriate name. For example, to run the small model, enter model space YOLO V8S. I don't recommend running a model larger than the small one because they require more memory and processing power, and there's a serious case of diminishing returns past the small model. The results will be better, but not enough to justify the increased load on the GPU. If you'd like to disable YOLO detection altogether, simply don't include the YOLO tag. Doing this will make the program run exactly like the previous version of the app. Next, let's take a look at the advanced settings. The program continuously runs motion detection, and it only starts the YOLO detection if it detects motion first. It works this way in order to make it more power efficient. So if the default motion detection settings are providing poor results, additional arguments can be provided to tweak the sensitivity of the motion detection algorithm and to enable testing mode, which helps to find the optimal threshold value. These parameters work exactly the same as they do in the previous version of the program, so I won't be going over them today. If you're interested in modifying these advanced settings, then check out the video that goes over the previous version of the app. But generally speaking, the default settings should be completely fine, so you shouldn't need to change anything here. So that wraps up everything I wanted to go over for today. If you enjoyed this video, then be sure to give it a thumbs up. Also, if you found value in this software, then consider giving a donation. Anything helps, and it allows me to do bigger and better projects in the future, including more free and open source software such as this. The links can be found in the video description. In future videos, I'll be talking more about the code and how the program works. So if you're new to Python programming and want to gain a better understanding of how to do coding, then that video should be very helpful. I'm also planning to add more features to the project, including an automatic night light that's controlled by a Raspberry Pi. So if you're interested in learning more about circuits, then be sure to subscribe to the channel and stay tuned. But anyway, that's all for today. As always, thanks for watching, and I'll see you guys in the next one.